Okay, we are going to look at how to do unit conversions with moles. So first thing we need to know is that a mole is just a word that represents a number, like how a dozen represents 12. So a mole is 6.022 times 10 to the 23, a really, really big number. And the reason we use moles in chemistry is because atoms are so tiny, we can't work with individual atoms. So instead we work with moles of atoms. So when we're doing unit conversions, we start by writing out the number and units given to us in the question, draw your multiplication sign and your division line. The units that you're trying to get rid of go on the bottom, the units that you want to end up with go on top, and then you fill in the numbers so that the top and the bottom of this fraction are equal to one another. And when the top and the bottom are equal, that's like multiplying by 1. If you think of a number like 5 over 5, that's like 1. So if the top and the bottom are equal, we're just multiplying by 1. We're just changing the way the number looks and not the value of the number. So in this example, if you have 1.20 moles of carbon dioxide, how many molecules of carbon dioxide do you have? We start by writing down the number and units given to us in the question, 1.20 moles of CO2. Draw your multiplication sign and your division line. The units you're trying to get rid of go on the bottom. We're trying to get rid of this moles of CO2. So whatever units you wrote down over here are the units that you're going to write down here. Moles of CO2. And the units you want to end up with go on top. So you have to read the question and see what it's asking for. It wants to know how many molecules of CO2. So that's what we're going to put on top. Then we ask ourselves, what numbers can we put here so that the top equals the bottom? Well, unless you have moles on top and moles on the bottom, you're going to want to put a 1 with the moles. The only time you don't put 1 with the mole is when you have mole on the top and on the bottom. So we have moles and molecules. That's not the same thing. So we put 1 with the mole, and then we think how many molecules are in 1 mole? That's where we come back to Avogadro's number here. 6.022 times 10 to the 23 molecules are in 1 mole, so that's what goes on top. And then you would just do that on your calculator and find your answer with the proper number of sig figs. So 1.2 times 6.022 times 10 to the power of 23 equals, so I want 3 sig figs because the number I'm starting with has 3 sig figs, 7.23 times 10 to the power of 23 molecules of CO2.